Besides the measures of central tendency, there are some other measurements that are called of dispersion, and they are also very important if we want to have the big picture of what numbers are trying to tell us. Central tendency, as we saw before, is just one number that represents all of our information, just so we can compare two sets of data. We saw this were the mean or the average, the median, and the mode. Dispersion measures are representative of, they're also representative for a set of data, but they tell us how dispersed or how our data is in total. And we're talking about the range, the variance, and the standard deviation. Let's talk about an example. If we want to see how much the Kansas City Chiefs make every year, we have some measurements. Here, we can see that their total for the year, it's 197 millions. They have 40 signed players. And if you see here, this is how much of this total is going for the quarterbacks, how much of this total is going for the running backs, and all of the people that are in the team. So let's take a closer look at those numbers. If we're talking about the quarterbacks, and this was in 2021, so the numbers might have changed. The first quarterback, Patrick Mahomes, is earning around $25 million. The second and the third, you can see here, we have 4 quarterbacks, and the other ones are not earning as much. But if we take the average of this 27,000 and 27 million and we divide it over 4, we get around 7 million per quarterback, right? So that is the average. But we can see that that is not always true because Patrick Mahomes is taking like a big chunk of that 27 million. On the other hand, if we are talking about the special teams, so for example, the pointers, if we're talking about the special teams, we can see that in this case, we have Harrison Buckner, who is the kicker. He only earns around 4 million. The other one is James Winchester. He's earning 1.1 million. And Tommy Townsend, it's not earning even the $1 million per year. So we can see that the dispersion of how much people are making on the Kansas City Chiefs is very, very large. The same thing happens for basketball, right? If we see LeBron James, for example, this is his salary, $39 million. And on the other hand, we have some people here, Quinn Cook or Talon Horton, who are earning around 1.7 or 1.5. So this tells us about the range of the salaries of this sports team. The range is the difference between the highest and the lowest value in the set of data. If we go back to the Kansas City Chiefs, we saw that one was earning around this. This was the lowest, and I'm pretty sure that the highest is Patrick Mahomes with around $25 million. So we can see that central tendency, it's not something that we want that describes accurately our data. So we want something to see how the dispersion is, how much everybody is earning in this two sports team. Variance is another dispersion measurement between the data and the mean of the population. It is calculating by adding the square of the differences between each data and the mean of the population and divided by the total of data. We have two formulas. One, when we have sigma here and n here, we're talking about the mean of the population if we have access to the total population, like for example, in this two sports team. If we don't have the population, for example, if we were talking about a country or a state or, I don't know, an education system, We have an n minus 1 and an s. That's the difference. If you see the formula doesn't change that much, that is the difference. The total number of values in the sample, we have to subtract 1. And the letter here changes. When we have an s, it means that we're talking about the sample. And when we have a sigma, it's when we're talking about the population. The greater the variance, the poorer the quality of our data. So if you see this graphs right here, we can see this blue one. And because it is so narrow and so straight, we can see that there's not a lot of variance between one and the other. My mean is at 0, and all of our data points are very close to the mean. As I go to the red one, my mean is also at 0, but I see that my data points are somewhere over here. If I have the yellow one, and I'm going to erase, if I have the yellow one, I can see that my data is everywhere. So because I have such large variance, my data points do not look like each other. I think this would be the case for most sports teams when we have stars and then we have everybody else. On this other one, on the green one, if we see the green one, it's right here. My mean is minus 2, but we can see that the variance is not that bad, right? Because we have a very straight up, narrowish curve. So we can see that my variance is not that high. So you can see that the greater the variance, the poorer the quality of your data, because you are not able to make good decisions because of the variability. Like your data is not like each other. The standard deviation is the square root of the variance. So if we already have the variance, we just take the square root of it. Let me just complete this formula. We just take the square root of it. And that would be my standard deviation. The standard deviation is actually the plus minus that we see in a lot of places. For example, if I'm buying chocolate, if I'm buying, 100 grams of chocolate, and I have a plus minus 2 grams, that means that most likely my chocolate is going to weigh between 98 and 102 grams. So this is perfectly acceptable because they're telling me that their standard deviation is 2 grams. If we see this is the same graph that we had as before, this has a small standard deviation because my mean is right here and my data is not that far away. But as I see the blue one, I can see that I have a larger standard deviation, right? My data is all over my graph. Let's have an example so we can see what we do when we have standard deviation. So it says the ages of John's friends are the following. We have 4, 5, 3, 6, and 5. Find the mean, the median, the mode, the variance, and the standard deviation, considering that the whole population is 5. So it's only 5 friends than John has. So we already know how to get the mean. So the mean is just going to be the addition of everybody. I'm gonna put it in order just because I want to, not because we need to do this for the mean. So we have 5 friends, and if we add them all and we do and we divide them by 5, I get a 4.6. So that's my mean. If I want the mode, it is the most repeated one. So I see that the 5 is repeated twice. So my mode is 5. And then my median, because I already have my data from smallest to largest, I can see that my midpoint is also 5. So that's mean, median, mode. Now let's go into the variance. So I'm going to have 3, 4, 5, 5, and 6. The formula says that we subtract my mean from my data points. So I'm going to subtract 3 minus 4.6, and we have to square it. Then I have 4 minus 4.6 squared. I have 5 minus 4.6 squared. I have, again, 5 minus 4.6 squared. And then I have 6 minus 4.6 squared. So I calculate, you can do it in in one line, it doesn't matter. I'm just doing it the long way. We have 256, 0.36, 0.16, 0.16, and 196. The formula tells me that I had to add all of them. So I have a total of 5.2. This is x minus mu square. This is the summation. So now I have to have the 5.2 over my total number of data. Remember, this is population, so I need an n. So I have, this is 1.04. This is the variance. But the standard deviation, this is the variance, so is sigma square. But the standard deviation, it's going to be the square root of 104. And that is 1.02. This would be the standard deviation. So I can say John's friends are 4.6 years old plus minus 1.02 years. So that means that I can either have friends that are from 3.6 to 5.6-ish years old. That's what it means. Let's do another one. This is find the range, the median, the mode, the mean, the variance, and the standard deviation. And here we're talking about income in millions of dollars from a sample. So we're changing our formulas from a sample of manufacturing industry. So again, I'm just going to put it in order. So I have 15, 17, 23, 26, 27, 15, 17, no, I'm mistaken. I went from smallest to largest. So again, I have 15, 17, 18, 23, 26, 27, 26, 27, 29, 46, 65, and 72. So I have a total. I have an n of 10, but an n minus 1 of 9 because we're talking about a sample. So the range is highest minus lowest. So my highest in income is 72. My lowest is 15, which gives me a range of $57 million. The median, it is my midpoint. Because this is an even data set, I see that my median is 5 and 6. So my median is here. So that means that my median is going to be the average between 26 and 27. So it's 26.5. The mode, I have none because I do not have any repeated numbers. So all of the numbers are unique. And the mean, I add them all and I divide them by 10. So I have $33.8 million. Okay, so now to find the variance and the standard deviation. So again, I have 15 minus 33.8 squared. And then I'm going to have 17, 33.8 squared. I'm going to have 18 minus 33.8 squared, 23. And I do this with every data set until I get to the 72 minus 33.8 square. So I need to add them all, and I get an 8693.6. Because my data, I have a sample, this is going to be over 9. So this is already the summation of x minus x bar squared over n minus 1, which gives me a variance of 96.5.95. This is my variance. Because this is a sample, this is an S square. In order to have the standard deviation, I have to take the square root of the S square, so I get back an S. So I take the square root of 965.95, which gives me a standard deviation of $31.02 million. So that's what I have. I have a mean of 33.8 and a standard deviation of $31.08 million.